Hello folks, welcome to what's going to be a super exciting online video extravaganza where I attempt, crazily, to show you how to replace the OEM logic board in your MG drive unit with a new open inverter design. So we're going to be replacing OEM board, all kinds of OEM stuff on it, with this little beauty that I designed, which is based on the open inverter system. Hello. So, why would you want to do that? Why would you be crazy enough to want to do that? Well, you might want to use one of these MG drive units in your EV conversion project. But Damien, you're... Just a sec. You were saying? Oh yes, I'm doing it wrong. Okay. Why would I have to replace the logic board in my drive unit? Why can I not just run it as it runs in the parent vehicle via canned messages and whatever random signals that it needs? And that's indeed a valid question. And I answer this, particularly I used to answer this when I was doing the Tesla stuff quite a bit. But I'll answer it again here now because it is important to try to get the message across to folks. So, for example, if we take a fairly common drive system like the Nissan Leaf system, that can be ran via reasonably simple and well understood CAN messages, and it will behave as if it were in its parent Nissan Leaf or ENV van or whatever. However, a lot of more modern inverters and drive units, such as our MG friend here, are now integrating the vehicle immobilizer with the inverter. And so what that means is basically that the inverter, you can know all the CAN on how to run it, so your torque requests and startups and whatever else, but it will not enable drive unless it receives some encrypted message with the correct challenge response as required by the manufacturer. Now, contrary to some of the conspiracy theories, and I definitely am a conspiracy theorist, it's not just to stop people using these drive units in EV conversion projects. The primary goal of it, if you want to get into conspiracy stuff and leave, you know, things like insurance and car theft and all that aside, the primary thing is to stop people swapping drive units between cars. So if you have a failed inverter or a failed drive unit and you want to swap it from one that you buy from a scrapyard, you can put it in there, connect it all up, and it won't work unless the manufacturer gets involved. If the manufacturer gets involved, chances are they're not going to want you to do that anyway, so they will just say, nah, sorry, can't help you. So that's why we are going on our MG drive unit with a replacement logic board based on the open inverter system, which, as the name would imply, is completely open source and lets us control our drive unit. Now, there are some advantages to using the open inverter system, and the most notable one is that it's like a aftermarket ECU for an internal combustion engine. We can make this thing sing and dance to our commands rather than whatever limitations that the manufacturer may have put in there for purposes of meeting warranty and all that type of thing. Now, before I finish up this part, obviously people are going to be saying, oh, but Damien, you're doing it wrong because you're losing all of the manufacturer's information and all this. Yes, of course we are. Yes, would it be nice to be able to run these with a few canned messages? Of course it would. However, that's the way of the world today, folks, and we're pushing back against this to try to give you folks more options for your EV conversion drive systems. So, without further ado, that's enough of lecturing and conspiracy theorying from me. Yeah. So, I'm going to get on to it and we will show you how to assemble the board and fit it to your drive unit. Okay, folks, so in this segment here, I'm going to show you what that plan is. So our MG drive unit is controlled by one of these guys, which is the OEM Logic Board. Now, our goal for this is we're going to be replacing this one with this one. And now obviously your one won't have these random wires soldered onto it and so forth. But this is basically what we're going to be removing from the MG drive unit inverter. And we're going to replace it with this shiny new Openinverter Logic Board. Now this board has been designed to be physically a direct replacement for this one, so it's physically the same size, the same mounting holes. We'll use the same multi-way connector here for connecting to the rest of the inverter, like the IGBT drivers, etc. And we'll be using again the same type of a external connector here, so that everything is as close to being a straight swap over as we can actually get it. So if you purchase the board from the EV BMW web shop, you will get the board itself pre-programmed with whatever is the latest firmware that's available at the time. You will get one of these little multi-way connectors that you then have to solder onto these pads here. Now this connector, for those of you that would like to know, that's the information on it there. And that's also, all of this information is also available on the GitHub repository. That'll be linked in the video description. You will also receive a ESP8266 WeMOS type Wi-Fi module that you may optionally decide to fit here to the board for communication with it. Now, a lot of folks these days are using an external CAN-based Wi-Fi module, such as this LilyGo TCAN type of a thing here. So if you're going to use one of these with your drive unit, then there's no real need to fit this internal Wi-Fi module here. Now in my testing so far, I've actually been able to get a Wi-Fi signal from this out through the inverter casing. Now I have had to have this fitted in my development work, obviously, for communicating with the board, but the choice will be down to you folks, should you decide to use the internal or external Wi-Fi, but in any event you'll be supplied with the internal one. So I do not supply the external connector here, and the reason for that is that some folks may wish to attempt to harvest the connector from the OEM board and save themselves a few bucks, or may decide to purchase it from a local supplier. Again, the information on this connector is available on the GitHub repo. What I'm going to do here, just to see how it actually works out, is to attempt to harvest the connector from this OEM board. Now, some folks may think that, well, oh, it's okay, I've got a desolder pump. I'll just desolder all of these pins and it'll just pop out. Or you may think, oh, I have a hot air station. I can just, put some flux on here, heat them up, and it'll just pop out. The problem with attempting to do that, in my experience at least, is that boards like this, they'll of course be multi-layer boards, and they'll have various copper planes internally usually. And those planes will very quickly wick away the heat from the area that you're trying to desolder. And it'll make it very hard then to get all the solder out of the little tubes that go down through the PCB. So we're going to try a different method here. I've used it to some good success in the past. Now, I don't expect it to be super successful this time, and the reason is that this connector design has these little plastic tabs that come down through the board to help with alignment. So my preferred method is a gas torch, and the reason for that is that the torch will put a ton of heat into this very, very quickly. Hopefully let us pop the PCB off the plug before bad things occur. So, without further ado, let's try it. I've got a little bit of scrap stainless steel here that I'm going to hold in here to try to protect most of the connector from the ravages of the fire. So, let's prepare for the hiss. Oh no. Some kind of gas leak. Well, let's put that down here so that it leaks away from the torch. Oh yeah, that's perfectly safe. Yeah, unfortunately, as I suspected, we are going to melt those little tabs. Come on. Come on. Come on, let go. Got it. Now, because of the imminent risk of explosion. Oh yeah. As you can see, my gas hose here is perfectly safe. So, let's see how we fared out while that cools down. Ooh, let's let the pressure off it so it doesn't disintegrate. The good news is, folks, I think we got it. Now, I'm not obviously recommending this approach to you, but if you want to save yourself a couple bucks, this might actually work out. I did have to, because I only had two hands here, kind of had to go a bit crazy with it, but it did work, and we're able to, get it out of there. So, okay, success. So before I even thought about cleaning up the pins, I just said I'd have a look and see how this connector would fit, and to my surprise, yeah, that works out really well, even before I tried cleaning up the pins on this, so quite happy with that. So we'll obviously clean up those pins before soldering this in, but anyway, the next thing we want to do now is we want to solder in our multi-pin connector. That'll be in one of these little things like so, and it'll come with this little cover on it here. You can see that. So leave that cover on it until you have it soldered into the board. And it has these two little plastic pins on the back there that help align it with the board. Now, this connector does have a specific orientation, because if we see here, we can actually flip it around and solder it onto the board either way. And if you're anything like me, then you will probably end up soldering that onto the board the wrong way. So in order to avoid that, best thing to do is to get your OEM board and have a look at the orientation, and you'll be able to see, it's not going to really come out on camera here, but there's a little notch in the two end pieces here, and you want the little notched piece here on these two corners to be facing the edge of the PCB. So we'll do the same thing here, but before we put this on, what I'm going to do to make my life easier, I'm going to take some solder flux. It's the stuff, everyone always asking me this. This is the stuff that I use. I don't know, it's some kind of AliExpress Kingbo RMA 218. That's my tool of choice. So I'm going to take a line of flux, and I'm going to run a little bit on each end because there's two mounting pads on each end. And I'm going to run a little bit down on both sides here, just enough to cover the pads. Don't have to go nuts. Then referencing my OEM board again, I'm going to check I have these notches in the corners here facing the edge of the PCB. And we'll get this guy, set him on there, and the little plastic tabs will line up, and we're good to go. Double and triple check this, because yes folks, you betcha, during the development cycle I've put these on the wrong way around. So don't be like me, be like someone smarter. So we're going to need some solder. Now I'm not going to be using any magnification here or any fancy tips or anything. It's just a standard, I guess, I don't know, spade tip or shovel tip or whatever you want to call it on there, and just some good old-fashioned leaded solder. Just remember folks, lead in your petrol and lead in your solder. Lead is our friend. So I'm going to keep a little pressure on it. I'm going to solder my two end pieces here before we get carried away doing anything else. There we go. Okay, so that's our connector mounted, and yes, you betcha, we're going to do it again. We're going to take the OEM board, we're going to hold the two of them like this, and we're going to say, yeah, notch, 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 edge of board, thank you very much. So whatever chance you'd have taking this off when you only have the end piece soldered gets infinitely more difficult once we solder on all of these pins. So I'm going to do the usual kind of drag soldering methodology here. I'm just going to be hitting these like so. It's not a super hard connector to solder. The one on the Toyota Prius Gen 3 boards are actually more challenging than this one to solder. You just go I usually give it about 2 runs like this just to make sure we have a nice fillet of solder on there. And we do the other side, the same jazz. Yeah. Flux is your friend here big time, folks. I see people, you know, especially in the days that I was selling a lot of the Prius boards, there'd be people trying to solder those things like you'd solder a through hole part. So, you know, you'd solder each pin individually, and trying to do that with a fine pitch surface mount thing is just an exercise in pain. So save yourself some pain and just work away on it like this. Nice blob of solder on the back of the soldering tip. And basically what happens is the flux will cause that solder to want to go down to the joint. If you don't put flux on it and you try to do this, you'll just end up with a massive blob and it'll short circuit, blow up, and then you'll blame me. And that's okay, I guess. So there we are. Normally I would give this a visual inspection with a little magnifying glass and just check that there's no opens or anything else going on there. Not going to do that now because I managed to leave my magnifying glass back in the house, and I'm not going back in the house at the minute to get that. So next thing I'm going to do is I'm going to give this a little bit of a clean up. Is there everyone will start screaming at me now for not using an approved flux remover. Damien, you can't use brake clean on that. Okay, whatever you say, internet. Just going to get rid of as much of that flux as we can. Nothing like a bit of brake clean to do it with. There we go. One connector fitted. Now, we don't know at this point that this is all working properly, so we will be giving it a little visual inspection. Now, assuming that you're not stupid like me, you will have purchased one of these connectors, at which point you can just clip it into the PCB and solder the flipping thing in. But if for some reason you decide to join me in stupid land, well, then you're going to end up with something that looks a bit like this, that has somewhat scorched mounting tabs, and you've got a lot of kind of remnants of the old, what's the name of it, lead-free solder on there. Now, we don't like lead-free. Lead is our friend. So, now I am tempted to attempt to clean that off. Now, the way I would do that, if I was going to do it, which I might still do, is I'd use some desoldering braid, and I would, what would I do? I'd use some desoldering braid, and I would attempt to remove, at least on the outside pins that I can actually get to, that pesky lead-free solder. How dare it be free of lead? Beautiful lead. Lead pipes and leaded petrol and all the other wonders that lead brings to us. Lead poisoning. So I'm just getting rid of anything I can see here, I guess. It'd make the most sense to try and get rid of it. Now, there'll be certain bits I really won't be able to practically get into, which will be kind of down inside the internal rows of pins and that. But I'll try and get anything I can just remove without too much hassle. Oh, that's going to burn me, which is fine, as I deserve it, because this is kind of crazy. But yeah, I think that'll go on, folks. So let's see what we get. So again, I'm showing you this just because it is something that you could do. Well, like I said, my recommendation would be to buy the connector. Let's see here for a sec. And the one advantage you will have is that on my board here, the holes for the mounting tabs are quite a bit oversized compared to the OEM board. But that being said, that has actually gone in there very well. So when you do push any kind of a thing like this, it's very easy, especially when you can't see all the internal rows. If you're putting on something like this, it's very easy for one pin, and it will be a pin that you need of course, to have gotten pushed back. And you solder in all these, you think everything's 100%, but you've managed to push one of those pins back and it's not making contact, and then trying to take this back out and fix that is another nightmare. So a couple of little tricks I do on this, and a couple different ways you can do it. When you have the connector on, just run your finger along the rows, and you'd be surprised how easy it is to detect if there's one of those pushed back. Now there's one of those here, it's a little bit low, it's not pushed back, but it is low. And that looks pretty good. And another way you can do it is just use a little screwdriver, and just you'll feel you can kind of run it along like that, and you'll feel it hop. And if it hops over one, you'll also feel that a lot easier as well. Yeah, I think that's good to go. So let's try soldering that thing in. Again, what could possibly go wrong? So I am actually going to put a little bit of flux. I'm not going to go crazy with it. I'm going to put a little bit of flux down around these guys, because again, it is a salvage connector. And a little bit of flux won't hurt us whatsoever on here, and just helps everything go a bit easier. It's kind of a cheap crutch, and it'll give you a decent soldering joint. So what I usually do there is solder one on a corner, press the board down, melt it again, and let it set, and then that just helps to seat the connector back in there. And you can do the same on the four corners if you wish. Just push down, and then we're soldering. And it's just a straightforward way of doing it. You're just soldering a through hole connector. Then when we're done with this, we'll brake clean the whole thing again. Alright, soldered back on. My little paintbrush, my flux remover spray. Oh yeah. And paintbrush. Come here, paintbrush, to agitate the old flux around that. Let's give it another little hit of flux remover spray. There we go. Can't beat the professionalism here. And just like that, once I get the brake clean off my hands, flux remover spray, we have ourselves one Pro replacement logic board for our MG drive unit, complete with salvaged multi-way connector that, quite surprisingly, has worked out pretty darn good. Okay, folks, so here we have my drive unit. So first of all, apologies. I had planned to have another drive unit here by now to make this video. It would be untouched. Obviously this is my one that I've done all the development work on, so it's currently got the Openinverter board in it, and is working away. I purchased another one of these. It's actually for a friend, but I was going to have it here for a few days, and I could have used it then to obviously demonstrate the installation of our replacement board. But sadly, for whatever reasons, couriers or I don't know, shipping nonsense, it's not here. So we're going to be making the video with my drive unit here. So let's get a look at it. The inverter is the place that we're going to be working, which conveniently is right up the top here. It's retained onto the drive unit. This is just for information, by these bolts here. Now you don't have to remove the inverter at all in order to do this work, which is really good news. You do have to remove the lid, and there's a procedure for doing that. Now before you get into any of this, obviously there's, well, not obviously, depending on where you get your drive unit, there may be this kind of a, I don't know if you can see it here, it's a kind of an insulated cover, and there'll be a top shell piece that sits over here, and it's just held on with Velcro straps, and you can just undo those straps, take the top part off, and you'll be met with pretty much what you see here. Now the key differences will be, you obviously won't have this 3D printed land plate here. Instead you will have this guy, which is the OEM high voltage connector. So that's what you're going to see mounted in there. So the first thing that we're going to have to do when we want to take the cover off the inverter is that right underneath here, where the high voltage connector resides, there's a little metal plate. I'll get this guy out for you. And what we have is this metal plate, and there's a gasket that sits in a little groove that screws up underneath the bottom of the inverter here. Now there's little Torx screws, there's 4 of them. You can see the little green dots. And what I was able to do was just to use a little Torx bit on a vice grips and just go in there and loosen them, and then they just spin out by hand. Again, it would have been great to have been able to show you that here on an untouched drive unit, but basically what you're going to get then is that underneath here you're going to then drop this plate out, and you'll drop out the little gasket along with it. Now you want to keep those, obviously. I use one of these kind of Ziploc bags where I keep all my MG bits in it. So I'll bring you down here a little bit nearer, and it'll hopefully make a bit more sense then about what we're going to be doing here. Okay folks, so this is what you will actually see when you have your drive unit. Now, if you're lucky enough to have the connector to go on here, or can source the connector to go on here, then you won't need this 3D printed part. But if you do, then hang around until later on, and I'll show you how we use that. So, now that we have the plate off, now that we have the plate off the bottom here, we're going to go ahead and we're going to zip out 4 screws that are in this guy. Those screws are, amount of prior preparation I do for these videos, folks. These screws are some kind of torque size. Oh wait, there it is. Fortunately, it's so damp, everything has a layer of moisture on it. They're, what are they, T20? Yeah, I think they're a T20. So we're going to zip those screws out. Now, once we do that, we still won't be able to remove this guy. That's where our little access plate under here comes in. You will need a T30 bit, because accessible now up underneath here, you're going to find these two guys. These, where's camera? Here's camera. We're going to find these two fasteners with a T30 head on them. And our mission is going to be to get up underneath here with a T30 bit and get the, oh, that's not the T30, this is the T30. Get up here with a T30 bit and break these guys loose. Now, once we have that done, and these two fasteners out, we should then be able to remove, theoretically, yes, the high voltage connector socket, and we can just put those fasteners back in here to keep them safe. Now, so that'll be getting our high voltage socket off. As I said, if you have the plug for that, brilliant. Then you can just put this back in once we've done the board swap. If not, we'll be doing the 3D printing option. So, we've now got this guy off. The next job will be to zip out the, again, Torx fasteners that go all the way around the inverter lid, inverter cover lid thingy. Okay, now, next thing we want to do is going to be to remove the lid of our inverter. We do have to be super careful doing this. So around the periphery, we have a series of T20 fasteners. Now, I've only got 2 in mine because, again, I've been doing the development work on this, but I'm going to go ahead and zip out those 2. You would be zipping out the whole lot of them here. There we go. Now, we'll put those away into our plastic bag and keep them safe. Now, folks, this is a part I need you to pay some attention to, because right now the lid of this is sitting on 2 dowels and is ready to lift off. There's no sealant or anything like that here. There is a metal EMC gasket in here, though, that we do need to be conscious of. Now, if you just grab this and lift it up, you're going to have a problem. And the reason for that is, this is our logic board, and it's fitting in right now. If you can imagine, that board is screwed in to the lid upside down like this. And here on the back, the multi-way connector that we soldered in has a very fine pitch ribbon cable that's, I don't know if I'll be able to kind of demo this. It's coming off the back and curling inwards again to connect that logic board to the gate driver board that's on the bottom half of the inverter case. And as is the way with all automotive stuff, that ribbon cable is as short as humanly possible to allow the smallest possible human hand in there to connect it at the time of manufacture, i.e. not my big stumpy hams. So the way we're going to open this guy is we're going to lift from this end, so the end that has the multi-way connector and the coolant ports. We have to lift it up fully, a certain amount, to clear the locating pins, but then we're going to tilt it. We're going to open it like a book up to about 45 degrees or so, and that should let my ham in here then to disconnect that multi-way plug. So let's see how much of a mess out of this that I can possibly make, on camera of course. Okay, wish me luck. So I got a little flash torch as well. It's going to help us kind of be able to see things here, hopefully. So what I'm going to do is I'm going to lift. You can put a finger under this here. And we're going to have to lift front and back because we got to get her up. There we go. So we're now up off the pins and we can now open like a book. Now what I'd suggest you do is get a torch, have a look in there. You won't really be able to see this too well in my fantastic videoing, but you'll see there the lower board is our gate driver board, and right in at the back is where our ribbon cable goes. So I'm gonna use one hand to hold this guy open, and I'm gonna get in here and I'm gonna squeeze in the two end clips on the ribbon cable, disconnect it, and then we can lift away. So hopefully now that'll make a bit more sense. You can see the way that ribbon cable connects onto the gate driver board here and then connects upwards onto the logic board, which is the one that we're replacing. That'll be on the lid. So that's how short that is. So if you can imagine you tried to lift this up or even tried to fold up the lid fully, that's just going to rip that cable out of there. So now we have our lid off, but there's some differences here again in what we have now with our open inverter board versus what you would have with a plain untouched version here. The first thing that you'll have, if we take our HV socket, I'll just pop it back in there for a second, is there will be a little 2-core wire that runs through these cable ties from the center of this guy here to the center of the OEM board. So you'll have, I'm going to carefully modify this for you. You will have, get off. Basically what you will have is that OEM board in there, and there'll be a connector here on this white 2-way pin that goes all the way over to here. Now when you remove the high voltage connector socket here, that can be unplugged, and you can then unplug it and remove that from your inverter. All as that is doing is providing the high voltage interlock connection on the OEM high voltage connector. Now that isn't the only thing, unfortunately, that you're going to see differently. You will see, you won't actually see the board. Instead what you'll see will be this metal shield that will be sitting on top of our OEM board. So you'll see something like that, and those screws that we see there will be going down through this guy here. So what we'll do, we'll take ourselves, I think this is a T10, yeah, and we'll zip out all of these screws here. Now you might, after doing that, be tempted to think, oh well, I guess that's our board free to come out. It's not, because there is more. Now the good news is that these inverters, other than that ribbon cable being exceedingly short, they are actually quite friendly to work on. So once we've all those fasteners out, I'm going to come up to the connector here, and we'll see there's, yep, you guessed it, there's 4 more Torxies, and they're a little small one, which of course I have not prepared earlier for you. That one feels like it. What's that, a 4? No, that's a Torx 8. So we will change bits. Now what I'll do here is I'll just put one, oh, there is one still in the middle. There was me talking about being careful, and I still managed to miss one, even though I've done this quite a few times. So there you go, folks. So I'm going to zip out these. These are a kind of a little self-tapping sort of thing. So while you're taking these out, you can of course do your pole bar and say shoot a self-tapper into it. But please do not shoot a self-tapper into it. That would be bad. So once we've shot a self-tapper out of it, and of course then gone back in and remembered this guy in the middle, we can go back, can zip him out, more zippage. Then we'll be ready to lift out the board. So basically, instead of that board, what you'll have, you'll be looking at that OEM board in there like that. It'll be looking like, like that, basically. That's what you'll see when you open this guy up. We'll zip out all of these fasteners, including the one in the middle, the 4 on the face of the socket, and we can remove the EMC shield and remove the OEM board, and then we can do a kind of a reversal process and refit our open inverter board. So before fitting the logic board into the lid and then reassembling everything, you may wish to run a test on your system here to ensure that the logic board is working. You know, there's not a bad solder joint or something silly going on. Now, in order to facilitate that, and it was more kind of for my own sake during the development work, is that if we look at this part of the board here, so just above the Wi-Fi module, you're going to see 2 surface mount LEDs, D1 and D2, and underneath them there's a little bit of text. One of them, the bottom one here, says int L active, the top one says int H active. So if I bring up the board to you, hopefully you might be able to see it. You'll see those 2 little, there they are there, 2 little LEDs and the writing on the board. Now, the reason it took so long to develop this board, well, one of them, is the difficulty in communicating with these gate driver chips. If you want to know more about that, then please see the previous videos on the more nitty-gritty of the reverse engineering. But anyway, these 2 LEDs here will, under normal operating conditions, not be switched on. So if all 6 of these gate drivers are configured and running happily, those 2 LEDs will not be on. If one or both of them is on, it means at least one of the drivers here is not configured correctly, or has malfunctioned, or there's something weird going on. So that may be something that you wish to proceed with. So now I don't need to do that with the previous board because I know that that board works, but we'll do it here with this board just to kind of demonstrate the procedure for you. So the first thing we're going to want to do is to remove the little plastic cap that comes on the multi-way connector that we soldered in. Then we will take our logic board and we'll connect our, first thing we'll do is we'll connect our wiring harness to it. First thing we'll do is attempt to connect the wiring harness to it, because I'm an idiot and tried to connect it the wrong way. Because of course the board should be upside down. I still have real problems getting used to that. So once we have that guy on, tend to do then is put a little bit of something down just to prevent short circuits. And then we can take our board, and it's good practice for you connecting this guy up without that big metal lid in the way, because trust me, even though I said I've done this a few times now, it takes a bit of practice and it takes a bit of work. So you might even want to try it before before connecting the big wiring harness. You might also want to have some extra light going on or extra pair of hands, but once it clips in, it actually does clip in fairly easily. Now at this point, we're now good to apply 12 volts to our system here to run a test. Now, before we apply the 12 volts here, there is something that unfortunately I need you to pay attention to again, folks, because it's going to trip people up, and I know because it's tripped me up and I'm the moron designing this thing. So, it requires a minimum of 12 volts 5 amps to light off the combination of drive unit electronics here. Now when it's running, you'll nominally see around 220 to 230 milliamps at around 12 to 14 volts. But it needs that kick to wake up the system. So if you're using a lab power supply, as I tend to have here, it needs to have a minimum of 5 amps of available current to it. Some of my power supplies here are limited to 2 amps. And when I was trying to fire this thing up, even with the OEM logic board in there, it would make these kind of clicking sounds, and the power supply would be going into current limit and coming out of current limit. And I thought, oh, you know, I've got a wire shorted or something going on. No. It's just the way the power supplies are designed in this. They need a sharp hit of amps to wake them up. Now, however, tempting as it may be to say, oh, well, that's no sweat. I have a car battery here. I'll just connect that. And it's going to be fine because I'll put a 5 amp or a 10 amp fuse on it. No, that's not going to be fine. The 5 amp or the 10 amp fuse will indeed protect the wiring that you're using to power up the system here. They would do nothing to protect the electronics on these boards if there was a bad solder joint, if there was a component misplaced, or you bridge something or something silly, okay? So if you don't have a bench power supply with a 5 amp current limit on it, you can use a 12 volt car battery, but get yourself to 12 volt 55 watt headlamp bulbs, just any type from any car, just 12 volt 55 watts. Connect 2 of them in parallel and put that parallel string in series with the 12 volt battery supply to your drive unit. Now, what that's going to do is the bulbs, when they're cold, have a very low resistance, and that little shot of power that the inverter needs to wake up will not have time to heat them up. So they'll be reasonably transparent to the current as it's going in. But if there's something wrong in there, like a short or some other problem, then those bulbs will very quickly warm up, increase their resistance, and lower the potential short circuit current that can go into the drive unit and cause you damage. I'm going to be using this guy here in a minute, which is a 20 volt 10 amp power supply, and I'll have that guy set to 14 volts and 5 amps. So hopefully this will be visible. I'm going to punch the power supply on now. And we're now at 14.2 volts and we're drawing 220 milliamps. Now you will be able to see some, hopefully be able to see some red LEDs flashing in there, and yes we do. So we have what we should see for normal operations is one LED solidly on here, which we have. This is our 3.3 volt power, and then we've got one guy in here flashing, and the two over the Intel H and the Intel B are both off, meaning that we have just successfully configured the 6 gate driver chips on here. We're now powered up, and we are ready to begin the next phase. So next phase is we've connected our Wi-Fi and we can now access the web interface. And what we're going to do is we're going to go all the way down to the bottom. I'm going to click on the plot button, because that brings us all the way down. And I'll scroll up a little bit. And just above the serial, you're going to see two parameters here, int H and int L. And they're both showing as being on. And that's good, because that is just a representation here for us of the status of those two interrupt lines that the LEDs physically show us there on the board. Obviously you won't be able to see that when the drive unit's buttoned up and in the vehicle. So this gives us this facility here. If either or both of these were showing as being off, that would be bad. That would mean that we had some driver problem or driver configuration problem going on. Next, we're going to load the parameter file. Now, the only parameter file that I have at the time of making this video is the one that I use here on my bench testing system. This will be available on the GitHub repo, and indeed any other parameters that I get as I do further development with the drive unit and get it in the Volvo V70 and so on. So we load up params mgdu base. That is, again, at the time of making this video, and I'll hit apply parameter file, and that'll do its usual trick there. And we'll let that fill out, and then we will save off our parameters. Still going. Again at the, so we'll go for command save parameters to flash. We'll check that it's done that, which it has. And just again at the time of making this video, the version of software I'm using is 5.36R FOC. Okay, so next little test that we can run here, and keeping in mind we've no high voltage of any sort connected here, and it's not needed, is we're going to put the inverter into manual run mode. So we'll go to the testing area here. We just go from the off to the on. Then we can drop back to spot values and hit refresh. And up mode is in run. And that's very good. That means our logic board at least is happy. So again, we've no high voltage connected, so it's not going to do anything. We can just stick a random value into manual ID, let's say 25 amps, and press enter. Now, two things are occurring here. The first is that I can hear from the inverter the 8.8 kilohertz pitch, meaning that we're pumping some PWM in. Up on my bench power supply, I've now increased to just under 700 milliamps of current draw at 14 volts. And if we go down here, we'll just get some random kind of noisy values as the inverter attempts to generate current without any high voltage on there, which of course it cannot do, which is perfectly fine. So we're going to go back, set that back to 0, and my high pitch twining stops, and we're back to our 250 milliamps. Go to commands, stop inverter, and we're back to around 220 now. So that is about as far as we can go now without applying some voltage to the high voltage terminals. Status then goes to wait start, so again, that's very good. Okay folks, so with that simple test done there, I would be reasonably confident that we have at least good communication with the gate drivers. We can run PWM into them and so on. It's not a perfect test. Obviously a perfect test will be seeing the motor spinning. But we'll be having to do things like setting up the resolver and all that. Now, I'm not going to cover that in this episode. This is more just for installing the board and doing some basic tests, and it's probably going on too long already. Board. Anyway, sorry. So let's go ahead and get the logic board installed back into the lid. I'll show you then how to refit the lid with my big hands on there, and then we'll cover the high voltage connection scenario. So let the boredom continue. So now that we've done a bit of a test on our board, we're reasonably good to go to install it back into the drive unit inverter lid cover thingy. So a couple things. First would be to note that there is a gasket around the connector. So when you sit your board in like that, it's going to look like these hole centers are a little bit pushed backwards. And the reason for that is that gasket needs to be compressed. So if you then press the board a little bit that way, the holes line up. So what I've been doing so far is I've been just squeezing in here with my thumb, putting a middle screw in just a few turns by hand, like that. Then we take our little self-tapper thingies and we can turn the casing up and shoot a self-tapper into it. Or in this case, shoot one back into it. So just start them by hand, I find, because it's very easy with these kind of coarse threaded things to get them to kick off on a bad angle. Hope you're seeing this reasonably well. I think you are. So yeah, I've been on a bit of a binge of Mr. Polbarn's stuff recently. I just find it very relaxing. I'm sure it's not very relaxing for him most of the time. Now, let's give these little guys a zip. Obviously torquing them to the exact spec. Ooh, yeah, that's how you do it. So that's why now if we look here, we'll see all of the screw holes are pretty much lined up perfectly here. So we can sit in our rest of our screws. Now, you might be saying, Damien, you're doing it wrong. You have forgotten to put the EMC lid in there. And indeed, I did, folks. And forgot about it twice. I'm not putting it in here because this is my development system. And I'm using the Wi-Fi module on board here. Now, also, some of the skyline of some of these components does tend to interfere with it. So at the time of the version 2 board, you can't really reuse the EMC shield. Now, it's not a major problem. If you did want to protect this board a little bit, you could give it a zip with some, not tractor paint, but some high performance acrylic conformal coating. So before putting it back in. Probably a wise thing to do. Again, I'm not doing it here because I'm going to have this off and on multiple times in the future, doing various checks and tests and whatever else that I can find. So we're going to zip our fasteners back in here, like so. Apologies, by the way, today with the rain and the wind noise. There's not a lot I can do about it here in the old barn. It is winter. My barn is made from, well, there is actually 2 telephone poles in it, but also train tracks. So I don't know if that qualifies as a pole barn or a train track barn. So answers on a postcard for that one. Yeah, go on, go on, go on. Don't make a fool of me on camera. I can do that myself. Right. Then we're going to take our T, whatever it is I told you earlier, and torque them to spec. Now you may, again, when you're assembling this for yourselves and you're happy with it, maybe worth a little bit of blue tread lock on those guys, because keeping in mind that's going to be upside down, so you don't want one of these backing out and flopping around inside the inverter, because that would be bad. Now, if you're reusing the existing high voltage connector, you can at this time, if you wish, refit that back into the casing, so that you have that guy in there and just zip the 4 screws in there. Now, I don't have that for my drive unit, and for yourselves I'll assume that you don't either, so we'll be going down the 3D printing route. So at this point now, we can leave that off and we can fit this guy back on our inverter. Before we stick the cover back on, it's probably worth noticing here that these are our high voltage bus bars. Let me see if I can get you in a little bit nearer there. And this is where we can connect our high voltage battery. There's a 10mm hole in each of these, so they're well able to take a little short bolt like that should we need to do so, and I'll get into that once we get the lid on here. Now, I have found that putting the lid back on here is actually more tricky than taking the thing back off. So just to note, this is the metal gasket. This may come off when you remove the inverter lid. You can sit it back on there. It's got 2 little dowels, one up here near the high voltage and one down here at the opposite end to locate it. So, we'll take our lid and we're going to have to do a kind of a reverse course here. And I don't know if you'll be able to see this, but this is where we've got to connect. And you're going to see here, if I hold the lid up here, where I've got no problem getting my hand in, the cable's too short and it won't connect. Brilliant. So what we have to do is to immediately knock the gasket off. That's the first procedure. So let's replace the gasket one more time. And we got to try and sit this guy down at a fairly steep angle. And also kind of line him up pretty accurately. And then we can, yeah, there it is, get that plug in and make sure it's home. And then we can fold our lid back down, give it a little shake until we get it onto the dowels. So this will be the point now that we'll be putting our fasteners back on. Now I'm going to just put in 2 here because again I'll be messing around with this over time. So this won't be it won't be the last time that this guy comes off. So we'll just put in 2 for now. And of course torqued to spec. So with this back on, you'll have put in all the fasteners and all that there. The next phase then will be our high voltage connector. Alrighty, so like I said, if you have the mating connector for this, you can just skip this part because it won't have any relevance to you. For those of us that do not, Genius here has designed this guy, which is a 3D printed part that will replace this guy and allow us to use standard M20 compression gland, and we can put cables in through these glands and bolt them onto the bus bars in our inverter. So this is a prototype, obviously, because Genius, again, you can see I've had to file out some of the holes because I can't measure. I measure once and print twice. So by the time that you're seeing the video, I'll have fixed this and there'll be an STL file for this up on the GitHub repo for you, should you wish to pursue this method. Also, you'll note the back surface of this is completely flat. On the next one now, there's a little gasket groove in this, and it'll be able to take that gasket there that's in the OEM connector. So I will probably put an option for this to buy this on the web shop if people wish. It will be, freely available on GitHub, so you can 3D print your own one. This one's just made out of PETG. There's nothing special. The only concern is that the threads on this will have to be tapped out. Now, I do model the threads and the 3D printer does print the threads, but they're rough, so they won't let you thread in a nice M20 gland into them. So what you will need is a M20 by 1.5 tap. Now, you don't have to have a good tap. These are cheap and nasty AliExpress things. I think they cost me less than 20 euros. I wouldn't even I wouldn't even show these things a piece of aluminium, let alone steel. But they will perfectly happily work as a kind of a thread chaser and clean up the threads in a plastic part, right? So if you do have a good M20 by 1.5 tap, then by all means work away. But for Pete's sake, you don't need to go out and buy a Presto tap or something to clean out the threads on a piece of plastic. So once you have that done, you can take two just plain M20 glands, just cable glands. I happen to have a red and a black. You can be any color you like. And then we can thread those guys in here. And this will then give you a alternative part to this guy here, and you'll be able to pop that little gasket out of here and put it onto this one as well, because it'll have the gasket surface. So now that we have this, we can go back to the inverter and see how we would go about now connecting up the high voltage using this guy. Okay, so back at the drive unit, if we look at the area here where we would be connecting this guy, you'll see stamped onto the top casing. You won't see it here on the camera, but there's a plus and a minus. The plus being nearest this edge of the inverter here, or the back side of the drive unit. So that's the positive. So we would be putting our part on here like this, so that the red was facing the back. Now, for connecting high voltage to this for use in a vehicle, I will be using some 35 square cable. Now, for me just doing testing here, it's just any random garbage. I think this is 10 square that I have here, and it's also horribly hacked up and all that. But we'll show you one of these just to give you the idea, and you just, imagine this was 35. So you'd basically have an uncrimped end. Obviously I don't have that, so I've had to beat the tar out of this. And you could then feed that back through your gland here. So you'd be feeding a plain piece of cable back through. That would be your negative. Then you can crimp on a 35 millimeter 8. So a 35 millimeter lug with an 8 millimeter hole on there. And then we do, likewise, we do the same thing for the positive. Now, at this point then, we can kind of push that 3D printed part back down out of the way. And the way that I am kind of doing these now, again, it's kind of subject to change, but I'd rather show you something than show you nothing. What I have done is I take an 8 by, I think it's an 8 by 12, just plain hex bolt, pop it in through that guy there, and it'll be impossible to see, but we can basically then use the lug to fit the bolt down in through the hole that's in the bus bar. And what we can then do is take now you see here I have a nylock nut. Don't use this, okay? Instead use an 8 millimeter Nordlock and a plain nut. The reason you'd only use a nylock nut on anything with high power currents or that in it is when you join up two conductors, no matter how good the joint is, there's always a bit of resistance in there. And that resistance will cause a little bit of heat. And that little bit of heat will just soften that little nylon insert in there. Then the car will be vibrating as you're driving merrily. And that might just get a little turn, and then you have a little more heat and a little more turn, and then... So please don't do... Just use a Nordlock and a plain nut. And that actually makes it easier. I'm just been, again, this is just a testing rig setup. So you can put your finger up through the plate hole there and you'll feel where that guy is. So for a little pro tip, as they like to say, I've got a quarter drive 13 socket. I'll put one nut in and then put another nut in on top of that. So now you have that nut there better accessible. And then I'm going to put a little tug on the cable just to keep the bolt in place. And I do have to kind of contort a bit here to make this happen. Also because I'm too lazy to get down on the floor beside the darn thing. Now there it is. Once we get a few turns on that, we can then see that it actually didn't go on. Yay. Pro job, Damien. Well, thank you, Internet. That's very kind. Don't be like Damien. Be like somebody else with a brain. Yeah, don't be like Damien, folks. Don't be like Damien. Damien, idiot. Ah, I think I felt something bite there, hopefully. Otherwise, I'd be looking like a moron on camera. Oh no. Think of the fans, the sponsors, the clicks, the humanity. And the good news is, even with my stumpy fingers, I can get in here and kind of hold that fastener down. You know, I still didn't manage to get it on there. Wow. Yeah, you easily know I was on camera. This just went straight on the last time I tried to do this. There we go. Finally. Wow. So that's on. And then obviously with a Nord lock and a plain nut, this would be a lot easier. But there's plenty of room then just to get a combination spanner in on top of that guy. Oh, I put it in the wrong way around. Of course I did. Because I'm on camera. And there's nothing like making a prat out of yourself on live TV. Okay, so that's our negative on. And then obviously the positive is the one out here nearer the edge of the casing. So we can go whee, and yeah, no, that didn't go into it at all, as I'm on camera. Maybe I can pretend I'm not on camera. Oh yes, not on camera now, so everything will be fine. We're not on camera. No, the camera's dead. It just failed mysteriously. Oh, yes. I've dropped the bolt into the inverter. Yes. Exactly what I was hoping to do. So, we're just going to ignore that for the purposes of the of proceedings here. Not worry about it and pretend that we got that in there. So that's now perfect. That's not falling out. And then, basically what we can do is draw our 3D printed part up here, pop our 4 fasteners in there, and then tighten up the glands, and we get back to this kind of a setup here. So there you have it, folks, how to professionally make a fool of yourself on TV in multiple easy steps. You can just fumble things and then that's it. So, I'm going to cut this video here. I think you folks will kind of know now the basics, hopefully, of taking the lid off the inverter safely, swapping the board, doing a basic test, and then, you know, depending on what's your high voltage connection strategy, you can either use the 3D printed option or the original connector. Don't drop the bolt inside the inverter the way Moron just did, because if you do, then you have to open up the inverter casing again and get it back out. So, which is what I'm going to be doing after finishing this. So I know folks are going to be asking me in terms of the signal wiring harness, and there's pinouts for the connector on the inverter, and also the resolver and motor temperature sensor connector up on GitHub as well. And I will endeavour to draw up a little diagram for you of how they connect. Now, I have followed the OEM connections for things like the resolver and the motor temperature sensor. So if you do have a OEM harness, the low voltage signal one, with your drive unit, that will work for those connections. Now, depending on how you wish to control your drive unit, if you wish to use it stand alone, then you'll need some connections for like start signal and forward reverse and brake input and all that. The throttle connections are the same as the OEM harness as well, so if you've got some wire for that, that should work also. Just as a kind of a footnote, this logic board does not implement any kind of contactor or pre-charge controls. I don't want folks anymore using inverters and drive units for driving contactors. There's just too much capability there, or possibility for misconfigurations and various problems that can get expensive very quickly. So that's not on this variant of the board. So I'll also have a link in the description of the video here to the EV BMW shop where you can buy yourself one. Also obviously to the GitHub repo. So this board will be using the, as they say, stock FOC firmware from the Openinverter project. There are some differences in this, like around the gate driver control and configuration. I have been working with Johannes on that. So again, hopefully before too long, that'll be merged into the larger Openinverter system. So obviously, again, just to remind people, at the time of making this video, which is the beginning of December 2024, I do not have this drive unit installed in a vehicle. It's just being bench or indeed floor tested here at the present time. But again, there is a plan. I have a nice big Volvo V70 outside that'll be used as the test vehicle for this drive unit. And a friend of mine has bought one of these as well, so we'll have a second one in the mix fairly soon, at least spinning on the bench where we can get some feedback and so on going on. Should you wish to, you can find the schematics, Gerber files and board layouts on the GitHub repo, completely free, so you can see how the board's laid out, you can see the circuit diagram, all that. The manufacturing files for JLC PCB will only be available on the €10 a month tier on my Patreon, and there'll be a link in the description for that as well. So if you do wish to make your own board, you will have to get on my Patreon for at least 1 month, give me €10 of your hard-earned cash, and download those files for fun and profit. This has been a much longer development than really it should have been, in terms of it didn't need to be this hard. Now, part of that was due to me having a lot of other projects going on, but most of it was due to the NXP gate drivers being hidden behind a NDA wall, or whatever you want to call it. And if you want to know more about that, then please do look at the videos preceding this one in the reverse engineering series. So that's enough talking. I'm sure this video is uber boring. We get 0 clicks, which is excellent. I would advise folks though, if you are, thinking about this, then do watch, do learn, because I would absolutely hate to see people repeating my stupid mistakes, like ripping the thing off or blowing chips on the boards and all this kind of thing. Because at the end of the day, that's why you pay me the big bucks, so that I make these screw ups, so you folks do not have to. So that's it. Wrap it up there. As usual, thumbs down. Do not share it with people in general, but if you know people looking at this MG Drive unit, do share it with them, because it might help them along for the aforementioned reasons. Also, will be links in there for GitHub, Openinverter forum and all that good stuff, and some other channels in there as well that you may find interesting. So that's it. I'm done. I'm going to go fish the bolt out of this thing that I just dropped in. And we will hopefully see you in the next somewhat less boring episode. And until that time, happy bolt fishing.